When writing the piecewise function for an application question, your first responsibility is to make sure that you can identify where the domain split happens. Sometimes that location is fairly obvious. Sometimes you have to work for it. This is one of those situations where it's pretty obvious where the domain split should happen. If you're interested in reading the question, please pause the video and read it now. So our responsibility for this question is to write a piecewise function that would model our membership at this gym. They want us to write a function C from a number of visits. Now, as I mentioned before, well, the first thing we want to do is identify where the split is going to happen. It's clear from the phrasing of the question that the split is going to happen once we get to this 15 visit mark. So, from the beginning, all the way up to the 15th visit, we are obligated to pay only $35. We're not putting an X on the 35 because that 35 is not conditional. It's not based off of the number of visits. That 35 is happening whether we go once in the month, 10 times in the month, up to 15 times in the month. What's interesting is when we get above the 15th visit. When we get above the 15th visit, we are obligated to still pay the $35, but we're only going to pay the extra 8 for any visit above the 15th. So logic would dictate that we would write the function like this. The $35 we're going to have to pay plus $8 a visit. But unfortunately, if you imagine this, say I used a 16th visit. I'm not paying $8 for all 16 of those visits. I am only paying $8 for the one visit past the 15th visit. That's going to change how we write our inequality. We want this 8 to only apply to those visits that are beyond the 15th visit. The way we do that is by lowering the number that we multiply by. Now, if I was to put 16, 17, 18 visits into this part of the piecewise, sure, I'm still going to pay the $35, but I'm also only going to be paying that extra $8 for those visits above the 15th. I have no obligation to pay that $8 before the 15th visit. You can leave this part of the piecewise like this because it really does help to tell the story of the gym membership. However, you also, if you wanted to, could distribute that 8 and simplify and create a shorter slope-intercept version of that half of the piecewise. Depending upon your interest level, depending upon what you need, you may want to leave it like this to show that separate 35 and to show that separate $8 for every visit past the 15th. But if you're the one typing this maybe into a graphing calculator, or maybe you just want this to be as simple as possible, maybe you aren't so concerned with telling that story and you want the calculations to be easier and you want there to be less of them, then doing that simplification once is beneficial to that work. So any one of these can be a reasonable representation for the second half of the piecewise function. Now, looking at the graphs of the parts of the piecewise function and identifying our domain in exactly the way that we did for each part of the gym membership, we see that we get this horizontal section where we are consistently paying $35 no matter how many visits. Now, this domain is a little bit misleading. If we really wanted to do this accurately, we would create what's called a discrete graph where there were individual points. 1 visit, 2 visits, 3 visits, 4 visits. There's no such thing as a 4.75th visit. You either go to the gym or you don't. So the linear function, as it's defined in this equation and in this piecewise, leaves a little bit to be desired, but we understand that it has its limitations. And we have $35 all the way up until we get to that 15th visit. At the 15th visit, we're seeing that we're still paying the $35, but it's at that point where we transition over to the other part of the Piecewise, where every visit costs us an extra $8. We make sure that our slope is still 8, which it is. We love to see that these two parts of the graph connect. Despite the fact that this point down here is undefined, that's because I carried in from the blue line. You'll see that the blue line isn't identified or isn't defined when x is equal to 15. So I carry back, I see that I can start there. And after one visit, I should, as you might imagine, be up to $43. And after another additional visit, I should be up to $51 and then $8 from thereafter. This function ensures that I'm not paying that extra $8 beforehand. Now, if, for the sake of conversation, if I was to have left off that $35, if I was to leave off that $35 from the original equation, the function would look a little bit like this. Now, you can still get the information that you need from this. So you'll see after one at 16, I'm at $8. And you'll see at 17, I'm at $16. If I left off that initial $35 from the second part of the Piecewise, I get the extra amounts that I'm going to pay, but I don't get them in total with that 35 that I've already paid. So you can see where it's beneficial to take a little bit of time to make sure you do it correctly. You don't want, the whole intention behind a piecewise function is that when you substitute a number in from the domain, that you end up in exactly the correct location. Not, I have to do a little bit of extra work on top of that. The purpose of the piecewise is to be set up and ready to go. So it is important that we include that plus 35 so that that blue line actually starts at the end of the red line, as opposed to having to remember to add in the $35 that you already paid for the first 15 visits.